this video, we're going to look at the elimination method for solving pairs of simultaneous equations. In the elimination method, we're trying to eliminate one of the variables by adding or subtracting the two equations together. Let's have a look at the process. We start by naming our equations number 1 and number 2, just like the substitution method. And we need to choose whether we're going to add or subtract these two equations so that one of the variables is eliminated. Now, to decide which variable we eliminate, we look at their coefficients. The x terms, we have 2 as the first coefficient and 5 as the second. They're not the same, so whether we added or subtracted those two terms, we're not going to end up eliminating those x variables. But if we look at the y terms, we have 3y and negative 3y. They have the same coefficient, so that's the variable that's going to be eliminated, the ones that have the same coefficient. Now we just need to decide whether we're adding or subtracting the two equations to get that term to eliminate. The way we remember is if they have different signs, we add them, and if they have the same signs, we subtract them. Now, positive 3y in the first equation and negative 3y in the second equation have different signs, so we're going to add those together. Because when we do 3y plus negative 3y, that's the same as 3y take 3y, and that's going to give us 0. So let's go ahead and add our equations together. We add the like terms vertically. 2x plus 5x gives us 7x. 3y plus negative 3y gives us 0. And then we have 9 plus 12, which gives us 21. And we've successfully eliminated those y variables, which leaves us with 7x equals 21, which is a much simpler equation to solve. We divide both sides by 7, and we're left with x equals 3. So we found one of our variables for the solution, and we just need to find the other one. And we do that the same way as we did with the substitution method. So we're going to substitute x equals 3 into one of the equations. You can choose which equation, it will be the same solution for either. So let's substitute into equation 1. And we have 2 times 3 plus 3y equals 9, or 6 plus 3y equals 9. We minus 6 from both sides. 3y equals 3, and we divide both sides by 3, and we're given y equals 1. So we can write our solution as an ordered pair, and we say, therefore, the solution is x variable first, 3, 1. Now, our second set of equations is very similar. We start by numbering our equations 1 and 2, and deciding which variable is being eliminated. And that's the variable that has the same coefficient for both terms, or the same number in the coefficient. We have 1x and 1x in both equations. The y variables have a 2 and a minus 3, which is not the same number. So it's the y variables that are being eliminated in this case. And once again, we just have to decide whether we need to add or subtract to make sure those x variables are eliminated. If we were to add them together, we'd have x plus x, which would give us 2x. And that hasn't eliminated anything, so let's try subtraction. X take away x, that gives us 0, and that eliminates our variable. So that means subtraction was the correct choice. The signs are the same, both plus, both positive, and so we subtract. And then we look at the y terms, 2y minus negative 3y. Remembering that when we minus a negative, that gives us a plus. 2y plus 3y is 5y. Which equals 10 minus negative 5. And once again, we have minus and negative, and so that means addition. 10 plus 5 is 15. And that gives us the nice simple equation of 5y equals 15. So we divide both sides by 5, and we're left with y equals 3. And so now, once again, we substitute that value, y equals 3, into one of the equations, whichever one you prefer. Let's do equation number 1. And we have x plus 2y, y is 3, equals 10. Or x plus 6 equals 10. So we subtract 6 from both sides, and we're left with x equals 4. So we can write our solution. Therefore, the solution is x variable first, 4, 3.